Hey guys, and welcome back to 5 Star Physics. And today we're going to be talking about Isaac Newton. So, who was he? Well, Isaac Newton, you should get to know because he is the basis of all forces and actually all physics that you're going to learn from now on. You know his story. Pretty much one day he was sitting under a tree and an apple fell on his head. And the thought that went through his head was, how did that apple manage to fall from up there and come down here and hit me? And why did it hurt? What caused all of these things to happen? And he created something called forces to explain this all. And it's our next unit, Unit 2, which is actually my favorite unit. So Newton created three different laws. The first law is that an object in motion will stay in motion or that an object at rest will remain at rest. Pretty much what this means is that an object is not going to change. An object's velocity is not going to change unless it is acted upon by an external force. Like, say, for example, you have a ball in space that is just moving to the right with constant velocity. Unless an asteroid or a rock hits it and alters its course, it's going to continue to move to the right with that constant velocity forever and ever and ever. And in these cases, we always assume that there's no friction and that there's nothing stopping it. That's what Newton's first law also assumes. Now, Newton also created a second law, and this one is the most important one, and it's the one that you're going to apply when you solve in your AP Physics 1 classroom. And his second law goes as states: the sum of all forces, or sigma force, the sum of all the forces in the system, is equal to mass multiplied by acceleration. And pretty much what this helps you do is it helps you solve for an object that is accelerating that doesn't have to be constant acceleration. And here's what I mean. In kinematics, when you were solving for acceleration, you always had to assume acceleration was constant. But how would you solve for something if acceleration wasn't constant? The way that you would do that is by using forces, and that's why this law is really, really important. And when I talk about net force, what I mean by that is the positive forces, so the right forces and the forces going up, added to the negative forces, which is the forces going down and the forces going left. And we will talk about how all of those are visually represented in something we call a free body diagram in the future. But just know that this is your application, and this law is going to be extremely important when solving. Now, Newton's last important law was his third law, which basically stated this: that a force on one object is equal in magnitude but opposite in direction to that object's force on the opposing object. And here's what I mean. Say that you have your hand, okay? This is your hand here, and you are pushing down on a box. Your force on the box is A, your hand, on B, the box. So A on B is your force. But the box also has a force on your hand, and that force is B on A, the box on your hand. And these two arrows here, that your hand on the box and the box in your hand, are equal in magnitude. So they have the exact same value, except one is going down and one is going up. So they always cancel out. And this is very helpful, and this could be used to solve for, say, if it's asking you to solve for the magnitude of a hand on the wall, but it's only giving you the value of the wall on the hand. Well, if you know Newton's third law, you know that those magnitudes are going to be the same, so you can solve for the wall on the hand rather than having to go through a lot of other steps to solve for the hand on the wall. So earlier, when I mentioned Newton's second law, I talked about a free body diagram and the practical application of forces, like drawing them out. So now let's actually talk about what that is. So we call it an FBD, free body diagram, and pretty much what it is, it's like I said, a visual representation of the forces. So the center of your FBD is your CM, your center of mass. Center of mass is where all the physics in a system takes place, because you can't cover every single part of the system. So instead, you find the center of mass of that system, and then you draw your forces around it. So surrounding the center of mass, we have four different forces. You're never going to have a diagonal force like this because, well, you will, but you will break it up into your horizontal and vertical components. You're never going to leave it as a diagonal, and you're always going to have it in these four directions: up, down, left, right. So as you know, right and up are positive, left and down are negative, and this is going to help you when you need to apply this to your sigma F, or the sum of all your forces. So let's look at this example here. Say we have an elevator. There's a cable attached to this elevator right here. And Let's say that it is moving down with constant velocity. Well, you know the center mass is probably approximately in the middle of that elevator, so that's where you're going to draw it. And then you're going to draw a downward force because we know that the earth is pulling on that elevator. And you're also going to draw an upward force because you know that that cable is also pulling up on that elevator. And because they're moving in constant velocity, we know that these guys are equal in magnitude, just opposite in direction. So that means that using your free body diagram, you would know that the sum of these forces would simply be 0. And so in that case, the acceleration would also be 0. So here are the takeaways that I want you to take away from this video. I want you to remember all 3 of Newton's laws because they are very important, and you will have to apply them on the AP exam. They are going to be assessed to you as common knowledge. But I really want you to focus on Newton's second law, which says that sigma force equals mass times acceleration, because that is going to be your main connection between force and kinematics and energy and all of these connecting factors. And that is the way that you're going to apply and solve every single problem you come across. Now, this leads us into our second takeaway, and it's our new problem-solving process. Before, the problem-solving process for kinematics was draw a picture, use your knowns and unknowns, and then apply your tools. In this case, it's a little shorter. First, you're going to just draw your free body diagram. You're going to represent every single force that's acting on the object in the system. And also just note here that forces have to be in contact. So that's very important to note. So you're not just going to draw like every little thing that you think is in the air. You're going to draw everything that's acting on the center of mass and that object. And that's what you're going to draw in your free body diagram. And then you're going to use that and you're going to apply that to your Newton's second law and the sigma force in your Newton's second law to pretty much solve and be able to solve for acceleration. Thank you guys for watching. I appreciate your time. And in our next video, we are going to be talking about all of the different kinds of forces you will come across and an example problem of those forces. Thank you guys again for watching, and have a good day.